Namaste. Myself Sachchida Nand, Assistant Professor, Department of Mechanical Engineering, with the Institute of Metrology. As we are in the continuation of the structure and their property and the materials and their mechanical properties. Now we reach to the various mechanical property of the engineering materials. So how these materials are withstanding at their position and maintaining their working environment as well, and continuation their support for the various structure. As you can see, this figure is from the Hava Bridge, and it is the very much identical piece in West Bengal, which connect the West Bengal and you can say the Kolkata and the Howrah together. So this is the kind of a bridge which are made in the time of the British, and this particular material is still standing over there from the decade, and this is how these particular materials are working in their particular working environment, and that's why we are always discussing that is how the material structure and their property is required to sustain their working environment and work according to their working condition. So the materials structure is a very important thing, and to bearing the load and various kind of effects, its property need to be fulfilled according to that working environment. So, if we are selecting any kind of a component, their mechanical property must be required to identify, and this is how we reach to this particular class that to discuss that how the mechanical property of engineering material impact the structure of that particular material, and to withstand that particular material for a long time to maintain their workability and provide a support in the human civilization. So this is the figure which is showing a various kind of metal structures which are connected each other and bearing the various loads. So these structures are basically distributing the load, and that load which contain the various kind of a mechanical strength, which is known as the mechanical properties. So when the vehicles are passing from this particular bridge, there are various kind of a load will act on this particular thing. So how this particular material is sustaining from the decade to decade and maintaining their statue over there, and symbolizing an engineering structure from the British time in the West Bengal. So now for considering all these things, this is very important things to know the various mechanical property. Why mechanical property? Because on any engineering material, there is a certain kind of a load will act, and that load should be sustained by that particular material in a specific way, and that is how this mechanical property is required to identify the various kind of a load which will be bear by the particular material that is known as engineering material. So sometimes there is a compression, sometimes there is a tension, there is shear, there is a creep, there is a fatigue, and there is a lots of loads that will act on that particular material, and that is why we need to study what is that particular properties and how it can be maintained, the particular properties of that particular material. So as you can see, this is the structure of that particular Japanese roller coaster. So this particular structure is made by some kind of engineering material. So, to finalize the material for an engineering product or application, it is important to understand their mechanical property of the material. Why? You can see the figure. How intricate these particular structure are, and how much kind of a mechanical load these particular things are bearing. This is the roller coaster ride, which is made by the pure metal, and this the circumference and the design, as you can see, where the bending and the stretching in that particular area, which all load bearing by this particular material. So it is very important to finalize the material before launching any product. So the mechanical property of a material are those which affect the mechanical strength and ability of a material to be molded in suitable shape, and that is how this particular structure are made, and they sustain their workability according to their working condition. So what is happening in the roller coaster? It's not new the thing. You all are aware of that thing. There is a roller coaster ride. There is a vehicle traveling with carrying the lots of people in it, and they are moving around as per the structure is moving. So when the particular load is moving around this particular structure, what is happening over there? There is a various kind of load will apply on that particular material. So if that particular material don't have that load carrying capacity, how this particular structure will survive and how this particular roller coaster ride will complete. So for providing any kind of a material, it is very important to choose that particular material according to their working condition, and to know the particular mechanical property, that how much and how there are different kind of a load will apply on that particular material during their working, and not after their load will remove. So how these things are working, this is the very intricate shape and size which is showing in this particular figure, and that is how that particular mechanical property is play a very vital role to withstand these conditions and maintain the structure in a very efficient way to work for a long periods. As this is the various kind of a mechanical property of the material, which includes the strength. Obviously mechanical strength is much more, which is strength means that including all the things. So the toughness, the hardness, hardenability, brittleness, malleability, ductility, creep, slip, and resilience, and the fatigue. These all are the basic of your, you can say, basic mechanical properties. As this particular figure is showing, there is a extension bridge which is loaded by these particular wires, which is carrying all the load of this particular bridge and possessing and maintaining the tensile and compressive load in it. So these all wires which are made by the metal having the load carrying capacity like that particular tensile strength and the compressive strength. So how all these are managed? These all are managed by this kind of mechanical property of that particular material. And after analyzing this kind of a working environment, the material is to need to be taken care. And after that particular loading carrying testing, these particular material are selecting for this kind of a structure. So moving toward what is the strength. So as you can see, this is the bridge which is carrying carrying the you can say railway track maybe. Yes, this is for the railway tracking, and another kind of a structure also. So strength, it is a property of a material which oppose the deformation or breakdown of a material in presence of external forces or load. So the strength means to bear the external load without deformation or the breakdown. That means that how much energy you have to sustain that external load. ऐसा कहते हैं ना कि the people, that person have very much strength, either mentally strength, either the physical strength. Why? कि अगर उसको मारोगे तो उसको असर नहीं होगा. Why? Because it resists that particular impact, it resists that particular load, and that is how the strength is defined by these things. And as you can see this figure, this particular structure is carrying the various kind of a load and maintaining the load according to their working condition, and maintaining the balance and the strength of that particular structure by sustaining the external load without deformation and breakdown. So that is how the strength is to be defined. The meaning of strength कि कितना ज्यादा एक्सटर्नल लोड को अपने ऊपर वो सह सकता है बिना टूटे हुए, बिना अपने शेप एंड साइज को चेंज किए हुए, and that is the meaning of that particular strength with related to the mechanical property. Now the toughness, how tough particular material is. This toughness is basically also related to the impact loading. As you can see, this is the figure that how much the energy that particular material is absorbing without fracture. और जब वो फ्रैक्चर हो जाएगा तो क्या मीन्स इतना जो जूल एनर्जी पर्टिकुलर मटेरियल अपने अंदर सस्टेन कर पा रहा है, इससे ज्यादा वो इम्पैक्ट लोडिंग को इतना टफ वो इससे ज्यादा नहीं हो सकता. So what is written here? It is the ability of a material to absorb the energy and get plastically deformed without fracturing. Right? So this particular figure is also showing a crash test, impact test of a vehicle, which need to be sustain that impact loading, means to absorb the load when the impact load is applied on it. So what is happening? According to this definition, it is fulfilling, and beyond that it is showing that how much impact load, how much stuff that particular material which absorb the energy to maintain the safety of that particular vehicle. So its numerical value is determined by the amount of energy per unit volume. So its unit is in joule per meter cube. Okay, so the value of the toughness of a material can be determined by the stress strain characteristic of the material, that is the force applied particular area, that is how it is expanding. And for good toughness, material should have good strength as well as ductility. So in the brittle material, having good strength but limited ductility are not tough enough. Conversely, material having good ductility but low strength are also not that tough enough. So therefore, to be tough, a material should be capable to withstand both high stress and strain. So that is how this particular toughness is to be defined. Now, the hardness, that how hard this particular material is. How you will define that particular material is hard? कैसे आप डिफाइन करेंगे कि कोई मटेरियल इतना हार्ड है? कैसे उसकी मैकेनिकल प्रॉपर्टी डिफाइन हो पाएगी कि वो मटेरियल हार्ड है? तो अगर कोई मटेरियल हार्ड है तो उसको तीन तरीके से हम डिफाइन कर सकते हैं. एक तो स्क्रैचिंग हार्डनेस मेथड से, एक इंडेंटेशन हार्डनेस मेथड से, और दूसरा रीबाउंड हार्डनेस मेथड से. सो first we will focus on that particular hardness definition, the property of hardness, how it is defined. So it is the ability of a material to resist to permanent shape change due to external stress. There are various measures of hardness: stretch hardness, indentation hardness, and rebound hardness. So the property of material that resists the permanent shape changes. Shape changes, how it will happen? When some kind of a scratches is happening on that particular material. If that particular material resists the particular scratching, that means that particular material is hard as compared to the scratching material. If the scratching, that you can see in this particular figure, where is the cursor? Right. So this is the indenter type, that is the scratching material, and this is the material on which the scratch test is to be happen. So what is happening? There is a scratch mark is drawing on that particular material. If that particular material will not possess any kind of a scratch mark, that means that particular material is harder than that particular scratching. So that is how we define that particular scratching of that hardness of that particular material, that this particular material can resist the scratching of that particular loading, right? And in the similar way, the second, that the scratch hardness is the ability of material to oppose the scratches to outer surface layer due to external force. What is happening over here? अगर ये इसको सस्टेन कर लेगा, इट मीन्स ये हार्डर है इस पर्टिकुलर डिवाइस से. अगर स्क्रैच बन जाएगा तो इसका मतलब ये हार्डर नहीं है इससे. तो हमें पता कैसे चलेगा कितना हार्डर है? तो ये जो पर्टिकुलर स्क्रैचर है इसका कुछ हार्डनेस वैल्यू होगा, उससे हम डिफाइन कर पाएंगे कि ये कितने हार्ड स्क्रैच हार्डनेस को रजिस्ट कर पा रहा है कि नहीं कर पा रहा है. दूसरा क्या है? इंडेंटेशन इज द एबिलिटी ऑफ अ मटेरियल टू अपोज द डेंट. डेंट मतलब छेद करना, गड्ढा करना. सो ये आप देख सकते हैं हेलिकल गेयर है, उसके ऊपर यहाँ इंडेंटेशन हम मान रहे हैं. जैसे कि हमने हार्डनेस टेस्ट में आपको बताया था, ये एक इंडेंटर है डायमंड कोड इंडेंटर है जो उसके अंदर एक चुभाएगा, चुभने वाला काम करेगा। तो जितने अंदर तक वो चुभा देगा, इट मींस that particular material is resisting that particular material up to that particular load, और उस लोड के बाद अगर जितना देर तक वो वहां तक रेजिस्ट कर लेगा तो उसका हार्डनेस वो डिफाइन हो जाएगा। एंड देन अगेन द नेक्स्ट वन इज द रीबाउंड हार्डनेस। It is the hardness is also called as the dynamic hardness, and it is determined by the height of the bounce of a diamond tipped hammer dropped from a fixed height or the material. That is particular thing which as you can see one of the very basic example, अगर आपने देखा होगा पत्थर तोड़ने की जो मशीन आती है, एक ड्रिल आता है, एक बहुत ज़्यादा आप इस फिगर में जान के देख सकते हैं, तो एक इम्पैक्ट टाइप में चीज़ है, अगर वो उस पर वो गन की तरह ट्रिगर करेंगे और ट्रिगर करके वो उस पर स्ट्राइक करेगा एंड देन रिवर्ट होगा, तो कितने पर्पस से वो स्ट्राइक हो रहा है पर्टिकुलर आप इस फिगर से देख सकते हैं। ये गन टाइप में है, ये कंक्रीट का एक मटेरियल, कंक्रीट का एक वॉल है जिसके ऊपर ये रिबाउंड एक्सपेरिमेंट को परफॉर्म किया जा रहा है, और ये पर्टिकुलरली फिगर उसी को शो कर रहा है, that is showing how this particular rebound hardness is to be checked of that particular material to know the how much hardness this particular material is possessing. So हर मटेरियल की रिक्वायरमेंट अलग है। अब आप देख सकते हैं कि तीन तरीके से हमने हार्डनेस को डिफाइन किया। तो अगर हार्डनेस की हम बात करें तो ability of a material to resist the stretch and the indentation in the material, and as well as the rebound, that is the particular next thing is added is also, that is the rebound, is mean that is the impacting you are providing in this particular material and how that particular thing is reverting. So that is how that particular hardness is defined by the property of the material by various kind of experiment. Now after hardness, what is the hardenability? So it is the ability of a material to attain the hardness by heat treatment processing. So what is heat treatment process? It is a process to recrystallize a metal for better improvement or create, or you can say the enhancement of that particular material's property. As the material is hot, but after the heat treatment it enhance their property to change their crystal structure and to regain their crystal structure, or you can say to rebuild their crystal structure to perform in a various kind of situations. So it is determined by the depth up to which the material become hard. The SI unit of hardenability in the meter is similar to the length, and the hardenability of a material is irreversibly proportional to the weldability of a material. As you can see, this particular figure is showing, and this graph is also showing the hardenability. This is the flat ground alone and the Rockwell C hardness test. These are all divided, and that is how this particular hardenability of that particular material is defined. So heat treatment एक ऐसा प्रोसेस है जिसमें बने हुए मटेरियल के प्रॉपर्टीज को फिर से इनहांस करने के लिए उसको एक सर्टेन टेम्परेचर पे गर्म करते हैं और तरह तरह के मीडियम से उसको ठंडा करते हैं। ठंडा करने का वही प्रोसेस है जो सॉलिडिफिकेशन क्रिस्टल स्ट्रक्चर का होता है। तो जिस तरह से आप उसको ठंडा करेंगे उस तरह से वो स्ट्रक्चर को गेन करेगा और उसी तरीके से मटेरियल की प्रॉपर्टी को वो इनहांस करेगा, जो कि हम लोग पहले भी बात कर चुके हैं। इन लेटर ऑन इन द यूनिट्स we will discuss what is the heat treatment in detail. Now the brittleness, as you can see, as you know also, the brittle material is the very less you can say the strength according to these kind of things, but not all for the materials also. But for the lighter material that will possess, as you can see, this is the terracotta cup which is broke down very easily, but this material is not easily broke down. So the brittleness of a material indicates that how easily it gets fractured when it is subjected to a force or a load. When a brittle material is subjected to a stress, it absorbs very less energy and gets fractured without significant strain. It doesn't process the stress strain graph. जब भी आप स्ट्रेस स्ट्रेन ग्राफ ब्रिटल मटेरियल का डक्टाइल मटेरियल से कंपेयर करके देखेंगे तो आप देखेंगे कि जहाँ से प्रोपोर्शनल लिमिट स्टार्ट होगी वहीं पर ब्रिटल मटेरियल फ्रैक्चर कर जाएगा। वो प्रोपोर्शनलिटी लिमिट के आगे नहीं जाएगा क्योंकि उसके अंदर परमानेंट फ्रैक्चर होने का चांस नहीं होता है एज कम्पेयर टू डक्टाइल मटेरियल। और डक्टाइल मटेरियल के ग्राफ में देखेंगे स्ट्रेस स्ट्रेन के, तो आप प्रोपोर्शनलिटी लिमिट से यील्ड स्ट्रेंथ की तरफ आगे बढ़ते हैं और अल्टीमेट टेंसाइल स्ट्रेंथ होते हुए तब वो फ्रैक्चर होता है। मींस इट प्रोसेस द elongation, but this particular brittle material does not possess any kind of a elongation, but it possesses a good impact test, impact strength also, and possessing a better toughness of the material. And that is why it is utilizing for making a product like an anvil and the hammer also, because they are continuously hammering, they are continuously providing the load, and that is the impact load sustainability ability of that particular brittle material is very high, and that is how the brittleness is defining. So brittleness is converts to ductility of a material, and the material is temperature dependent. Some metals which are ductile at normal temperature become brittle at a low temperature. As we talked in the earlier introduction class, that is how the titanic was shaped. That the transformation of the higher energy level to the lower energy means the atomic structure of that particular ductile material changes from ductile to the brittle material, and that's why that particular titanic was shaped. And that's why these things are happening. Malleability, the malleability, as you can see, that is the property of a material which is beaten by the hammer and can be changed into the sheet. But this is the example, not the definition. So malleability is a property of a solid material which indicate that how easily a material can deform under compressive load. How that particular compression, that is we are compressing that particular material, and due to that compressive stress, that particular material change their shape from the thick material to the very thin material as they change into the shape to the sheets. So malleability is often categorized by the ability of a material to form in the form of a thin sheet by hammering or the rolling process, as you can see in the figures. Now, this mechanical property is an aspect of plasticity of the material. Obviously, if the plasticity is not present there, that is not possible to change the shape of that particular component from one phase to another. So, with the rise in temperature, the malleability of the material increases. That is the change. How that particular, that is easily deformed into the sheet by the rolling or by the pressing or by the hammering. So that particular malleability is defined by this kind of thing, and that is why it is very much required in the steel to provide a various kind of a shape and size. As you can see, one is the gold, which is converted into a coin, and one is the steel which is converted to the small strips which are utilizing for various purposes, and the sheet metal processes. So as you can see, this particular material which is changing their shape from one roll, strong roll, to that particular thin sheet. And what is the use of this sheet? As you can see, there are lots of working on this particular sheet, which is utilizing. जैसे बोले तो छत पे हम लोग लगाते हैं घरों में, उसका काम होता है, शीट मेटल का काम होता है, बक्से बनाने के काम में आता है, और भी बहुत सारे ऐसी चीज़ें हैं जिनको हम लोग यूटिलाइजेशन करते हैं एक पर्टिकुलर शीट की मदद से, बहुत सारी चीज़ों को बनाते हैं। आप अगर देखें तो जो हमारे घर में स्टील के बर्तन हैं वो भी इन्हीं तरह की शीट से बनाए जाते हैं, जो एक मटेरियल को रोलिंग किया जाता है, शीट में बदला जाता है, फिर उसको मशीनिंग के थ्रू डिफरेंट शेप एंड साइज में चेंज किया जाता है. तो दैट इज हाउ दिस पर्टिकुलर malleability material mechanical property is required in the metal, so that various kind of a component and the structure are to be made. Now a very common, a very most important property of the steel, that is the ductility. So what is ductility and how it happens? It helps to maintain the property of the particular material. So as we saw in the particular figure that there is a bridge which is hanging by the wires. How that particular happened with that particular wire? It is just because of the ductility of that particular material is able to sustain that kind of a load. So ductility is a property of a solid material which indicate that how easily material get deformed under tensile stress. So the ductile is often categorized by the ability of a material to get stretched into a wire by pulling on the drawing. As you can see, this is from the figures how that particular this is the figure of that particular pulley and the wire, and this is the string which are particularly hooked in, you can see, in the guitar or the musical instrument, sitar and guitar also, where these are particular extension mode is happening. And this is the figure which is used to examine the ductility of that particular material, that the single material is elongate from this point to this particular end point. That is how much stretching in the particular material is having, and that particular material is bearing the load. And that is why I shown you that particular wire bridge, that is that particular material having the possibility to sustain that particular tensile load up to that particular loading. जितना लोड, इतना ज़्यादा लोड उसके ऊपर अप्लाई करेंगे और कितने हद तक वो अपने डक्टिलिटी को मेंटेन कर पाएगा। अगर उससे ज़्यादा लोड लगाए तो वो क्या होगा कि वो ब्रेक डाउन हो जाएगा। सो इसीलिए हम टेंसाइल टेस्ट को परफॉर्म करते हैं डक्टिलिटी को जानने के लिए कि कितना स्ट्रेचेस, हम कितना लोड उसके ऊपर लगाएं कि वो मटेरियल अपने आप को स्ट्रेच करना शुरू कर दे और एक टाइम ऐसा है कि वो तोड़ दे। तो जहाँ से स्ट्रेचिंग परमानेंट डिफॉर्मेशन स्टार्ट होगा वहीं से हम मटेरियल की बेसिक कैपेबिलिटी को डिफाइन करते हैं। And that is how we select the material for making this kind of a structure, which I shown you in the particular figure in the beginning, that the bridge is maintained by these particular wires which are hanging to that bridge on the particular seam. So the ductility, which is ability of a material to get stretched into a wire and by the pulley or by the drawing. So this mechanical property is also as aspects of the plasticity of material and is temperature dependent, as it is again related, that is it is temperature dependent. It will change according to the situation of the temperature. There is a transition of the particular material, the transformation from the ductile to the brittle transformation. So it is just happening due to the change in the temperature of that particular material, and that is why it is happened with that particular titanium, and that is why that particular titanium changed their ductility to brittleness, and when it is struck with that particular iceberg, it destroyed that particular material, and the titanium was sent down into the ocean. And that's why we identify that particular ability of that particular material, that there is a possibility of changes of the tendency of the material when the temperature of the particular material will change. And that's why these things are need to be taken care when the particular material is to be working in this kind of an environment where the changes of the weather or the temperature is taking place in a very efficient and effective manner, you can say. So that's why this particular thing is required, and so on, that the ductility is very important to know the how much that particular material will stretch, how that particular material will elongate themselves to maintain the balance and to maintain the structure up to a band level. So from the you can see from the Howrah bridge to that particular hanging bridge, these all are maintaining that kind of things in their certain way. So now the next one is the creep mechanical and the slip property. So creep, that figure is the boiler to failure. So it is a very progressive modeling of failure. So the property of the creep is in the material, which indicate the tendency of the material to move slowly and deform permanently under the influence of external mechanical stress, as well as the exposure which is by the particular effect by the temperature also, constant temperature also. कि जैसा अगर कोई कंपोनेंट है लाइक बॉयलर है, बॉयलर में क्या है कि वहाँ पे लोडिंग और अनलोडिंग होती रहती है, स्टीम का प्रेशर बनता है फिर हटता है, टेम्परेचर का चेंज होना होता रहता है। तो ऐसे कंडीशंस में क्या होता है, मटेरियल टाइम टू टाइम अपने आप को डिग्रेड करता है, and that is how the creep is all about. So it results due to the long time exposure to large external mechanical stress within limit of the yielding, and the creep is more served in material that are subjected to heat for a long time, जिसमें हीटिंग और कूलिंग मोस्ट ऑफ द टाइम हमेशा होती रहती है, जिसमें टेम्परेचर का चेंजेस होता रहता है, लोडिंग और अनलोडिंग होती रहती है, तो वो तुरंत नहीं खराब होते हैं, क्योंकि उसमें पहले हम लोग बाकी चीजों को टेस्ट कर चुके होते हैं. बट आफ्टर some time of period, that particular material will start degrading themselves, and that the slip in the material in a plane with high density of the atom taking place, and that is how the stretching of slowly that the slip motion we discussed in the defect class, that is how these particular things are extending themselves. So that is how the stretching of the slipping of that particular atomic structure is taking place by the effect of mechanical stress as well as the temperature of that particular material, which leads to that particular failure of that particular tube in a certain time of a period. It is not the quick one, but it will happen after the year, 2 year, 5 year, 10 year, and so on. So that is the thing we need to be taking care if we are working in the various high production level. Now, the resilience is the ability of a material to absorb the energy when it is deformed elastically by applying stress and release the energy when stress is removed. As you know, all always the spring had that kind of tendency. इसको दबा देंगे तो चिपक जाएगा, छोड़ देंगे तो हट जाएगा. तो how it happened? It is happened just because of that tendency of that particular material. And why I am telling you all this? Because it is all are related to our daily life equipment, our daily life things. That is how these things are around us, and we are very much unknown about this kind of a tendency. That is how that particular material is behaving. Either we are cooking some kind of a food on a stove that's sustaining the particular balancing the heat from that particular burner and boiling the particular water. That is the particular heat resistant material. This kind of a spring is utilizing at a various places, either in the bicycle stand or in the shock absorber in the bikes and in the car also, and most of the everywhere where this particular kind of a loading is applied. So proof resilience is defined as the maximum energy that can be absorbed without permanent deformation. So the modulus of resilience is defined as the maximum energy that can be absorbed per unit volume of the permanent deformation. So it can be determined by the integrating the stress strain curve from 0 to elastic limit. Its unit is joule per meter cube. And the last but not the least, we will discuss more on the detail. The fatigue, it is due to the weakening of the material caused by the repeated or the cyclic loading, as you can see in this particular figure. That is due to the cyclic loading, why the load is applied by a certain time of a period on a particular component, it will have the tendency to break that particular material. And when a material is subject to a cyclic loading, a loading is greater than the certain threshold value, but much below the strength of that particular material, that is the ultimate tensile strength limit or the yield strength, the microscope crack begin to form at a grain boundary at interface, and eventually the crack reaches to the critical size. एक बाल के बराबर, बाल की पतली थिकनेस के बराबर एक हल्का सा क्रैक होता है ड्यू टू साइक्लिक लोडिंग, और चूंकि वो स्ट्रेस कंसंट्रेशन होता जाता है उस बाल की जगह पे, मतलब बाल के हेयर क्रैक की जगह पे, तो वो बढ़ते बढ़ते क्या होता है उस पर्टिकुलर मटेरियल को ब्रेक करने का काम करता है. So eventually the crack reaches to a critical size and this crack propagates suddenly and the structure gets fracture. So आपको पता भी नहीं चलेगा और सडनली वो चीजें हैपन हो जाएंगी, और ये बहुत ही कॉमन सा प्रॉब्लम है किसी भी स्ट्रक्चर में. So the shape of the structure affect the fatigue very much, and the square hole and sharp corner lead to the elevated stress where the fatigue crack initiated. As well as it is very much need to be taken care in the welding of two material, where the joining of the material is taking place and where the cyclic loading is very much applied. So at that particular joining of the material at the welding portion, the fatigue chances is very much. So that during the welding there need to be taken care of precaution to maintain the fatigue in the particular material. So for now I am holding this for this right now, and we will discuss more in the next class. Thank you.